Hi, this is a quick revision of Unit 1 and Unit 2 for the course Basic Chemical Engineering. So Unit 1 comprises of units and dimensions followed by the concept of moles and mole fractions. In units and dimensions, we are classifying units as fundamental unit and derived unit. Fundamental units are basic units, derived units are combination of fundamental units. These unit conversions are important for solving major problems. The system of units we followed so far on a CGS system of units, FPS, MKS and SI system of units. Moving to the next concept in Unit 1, we were talking about the concept of molecular weight, which is obtained by finding the ratio of mass and mole. And the next concept is when there is a mixture of components are available, we cannot go with molecular weight, we have to use average molecular weight. To find the average molecular weight, we have to know the total mass of the system and total number of moles in the system. Followed by, to find the mass fraction or mass percentage, we have to find the ratio of mass of a component by the total mass. Similarly, for mole fraction, moles of a component by the total moles. The fifth concept is to find the density of the mixture. When you have a mixture, we cannot use single density. Pressure into molecular weight by R into T. R is a gas constant, T is the given temperature. Molecular weight is the average molecular weight. The detailed problem solving in Unit 1 will be on. The questions will be given either mass, you have to convert to mole. They will give moles and you have to convert to mass. And you have to find this molecular weight, average molecular weight, mass fraction, mole fraction. To convert mass to mole or mole to mass, we have to use the molecular weight. You can refer to the detailed lectures in the videos. The third concept is liquid concentrations. After the invention of Avogadro number or moles, the concentration is mentioned using 4 different parameters. One is molarity, normality, molality and parts per million. Molarity is a moles of fluid by volume of solution, and molality is moles of solid by mass of solvent, and normality is gram equivalent by volume of the solution. ppm is mass of solid by mass of solution into 10 power 6. Moving on to second unit, we have mass balances and mass balance without chemical reaction and mass balance with chemical reaction. Mass balance without chemical reaction, we are seeing 4 systems. One is dryer, crystallizer, liquid extraction and mixer. And the next term is mass balance with reactions. So any mass balance problem, these are the major 6 steps. First we have to draw the schematic, then identify and fill the solid percentage and water percentage. And we have to write the overall mass balance equation. Then we have to write the solute balance equation. The solute balance equation can be written by multiplying each solid percentage with the respective stream. Similarly for solvent balance equation. Once we got all the 3 equations, we can solve it using either calculator or manually, and we can find the unknown streams and compositions. So this is a schematic of the dryer where there is 1 input and 2 outputs. In case of crystallizer, there is again 1 input and 3 output. One is water evaporated, then mother liquor, another is crystal formed, 3 outputs. You have to note down that all the water vapor stream will have only 100% water vapor and 0% solid percentage. Moving to liquid extraction, this is the system where we have 2 input streams and 2 outlet streams. So we will take the feed which has a solute. Another input is solvent, which is a pure solvent. When we mix both of it, the solute from the feed will move on to the solvent. The solvent with the solute extracted is called as extract. The remaining feed solution is called as raffinate. So each will have its own solute and solvent percentage. Moving on, next system is mixer, where multiple waste acids from different industries are obtained and they are mixed using this system and producing a acid mixture which has our required acid concentration. So every acid stream will have acid percentage and water percentage, and there is 2 inlet streams or 3 inlet streams, and there will be only 1 output stream in case of mixer. Coming to the last part, mass balance and reactions. There are 7 terms you have to remember for this examination point of view. 2 is about the progress of the chemical reaction, and 2 is about classifying the reactants, and next 2 is about the product. So first is extent of reaction is the ratio of difference in change in number of moles of components divided by the respective stoichiometry coefficient. You can calculate the conversion using this formula. Extent of reaction multiplied by stoichiometric coefficient divided by initial number of moles of the respective component. When you write the conversion for limiting reactant, we call it as the degree of completion. Next concept is whichever the reactant taken excess is called as excess reactant. Whichever the reactant that is consumed first is called as limiting reactant. To find which is limiting and which is excess reactant, we have to find the ratio of number of moles taken initially as well as stoichiometric coefficient. If the number of moles taken initially is larger than the stoichiometric coefficient, then the numerator is called as excess reactant and denominator is the limiting reactant. To find the excess reactant, we have to find number of excess reactant fed into the reactor minus number of moles of excess reactant required as per the stoichiometry divided by the number of moles of excess reactant required as per the stoichiometry. The last slide, the selectivity and yield. If there are two parallel reactions are happening, there will be two types of products. So moles of desired product found by moles of reactant consumed is called as selectivity. Moles of desired product formed divided by moles of desired product possible is called as yield. This is the quick summary of the first and second unit. These are the major concepts that covers in the Unit 1 and Unit 2. All the best. Thank you.